Hello everybody and welcome to a new video. This week we're going to be talking about resistors in series and parallel. This video is going to mostly cover a lot of math, although we'll have a quick practical demonstration. So, it's not too complicated. Resistors in series are very easy. If you have... Oh, squeaky. And I picked up a cat hair apparently. Alright, if you have three resistors in series, let's say this is 1K, and this one is 4.7K, and this one is 100 ohms. I'm using those values because I've actually got a handful of those set aside here. They're going to all add together. So it's going to be 5.8K in total. So resistors in series, super easy. The power dissipation also adds, if each of these is a quarter watt resistor, they'll be able to altogether dissipate about 1.2 watts. And that's pretty much it for series resistors. Really super simple. Now, I guess I'll go ahead and do the practical demonstration of series resistors right now. Where is the breadboard that I set aside for this purpose? Here I go again with being really well prepared for my video. Yeah. Way to go, Chris. Where the heck is the... Oh, there it is. Alright, so let's grab a 4.7K resistor. And we'll put this one just like that. And then we'll grab ourselves a 1K resistor. And put it just like that. And then we'll grab a 100 ohm resistor. I keep my resistors in little pill bottles with a sticker on the top to tell me the values. Pretty simple way of keeping track of them, although at some point I'll be receiving a shipment of stuff from China, as usual, that will contain some neat new toys that I'll be using. So, let's go ahead and set this to ohms. Is that reasonably visible? Yeah, it's okay. Grab something to kind of prop this up a little bit, make it more visible to the camera. Nope. Oh, that's reasonably good. Alright, so we'll just take this probe and put it there, and that probe and put it there, and wait for it to even out, and it's about 5.69, because these aren't high accuracy resistors, but it's close enough to 5.8. So, the next thing we're going to do is talk about parallel resistors. Now this is where the math starts to get a little more complicated. I'm going to go ahead and just erase the title here because we're going to need lots of room. Alright, so parallel resistors. This is where it gets weird. So, we're going to do the same example here, but we're going to put them in parallel like so. We'll say this is 100, this is 1K, this is 4.7K. Alright, so how do you calculate this array of resistors? Well, the equation is RT, or resistor total, equals 1 over R1 plus 1 over R2 plus 1 over R3 plus, and then so on and so forth for the amount of resistors you have in parallel. And then you're going to take that whole mess and raise it to the power of -1. Now that also, you can also do the equation like this: RT equals 1 over R1 plus 1 over R2, etc. So just like that. Now, let's go ahead and throw these values into the calculator and see what we get. So we'll go ahead and pull out my phone here, which has the nice calculator on it, and we're going to go, we're going to do the parentheses 1 over 100 plus 1 over 1000 plus 1 over 4700 equals, and then we're going to take that, and where's my, oh, I don't even need to shift. We're going to take that answer and go x to the -1, and we get about 89.2 ohms. Does this see that fairly well? 89.184 ohms. So let's go ahead and test that with a multimeter and see what happens. So for parallel, we're just going to move these resistors over to like so. There we go. Now, let's have a look at the resistance and see if it agrees with our math. So, let's go ahead and put these probes across those resistors, and we're going to get 87.6 ohms, which is pretty darn close to what we calculated. 89.1, what did we get? 87 point something. Wait for the auto. Yeah, 87.8. So it's still pretty close. Again, the error isn't in the math, the error is in these resistors. These are only 10% resistors, so they're not tremendously accurate. Anyway, let's set that aside now and talk a little bit more about parallel resistors. Now, there are a couple of shortcuts that you can take with parallel resistors. One of them, let me clean up my mess here a little bit. I'm going to have to track down that lid. Alright, we'll go ahead and put the 100 ohm and 4.7 k ohm resistors away. But we're going to keep the 1k resistors out. Where did that lid go? It went hanging off somewhere into the distance. Oh, it's way the heck over there. I'll pick that up later. Okay. But we're going to keep the 1Ks out just to play with for a bit. Now, let's say that instead of these values, we just have 3 1K resistors in parallel. Now, calculating this is actually a lot easier when all of your values are the same. You're just going to take the value of one resistor, in which case it's, well, actually, you're going to take the value of one resistor, which is 1K, and divide it by the number of resistors, in which case we have 3 resistors. And then we're going to get about 300, or 333 ohms. So let's go ahead and demonstrate that practically. So we'll grab 2 more 1K ohm resistors here, and toss them into the breadboard like so. There we go. And I already put my multimeter away. May as well keep this reasonably well accessible. Alright, let's see what we get when we measure this out. Wait for the auto ranging to do its thing. And we've got 329 ohms. So that's a rule of thumb for dealing with the same number of the same value of resistors when they're in parallel. Now, something else that's interesting about resistors in parallel is that, and this is one of those laws. I won't write it out because it's too time consuming to do, but I'll state it. The total resistance of any number of resistors in parallel is less than the smallest resistor in the lot. So basically, earlier when we had the 4.7K and the 100 ohm and the 1K ohm resistor, they all came out to a resistance that was less than 100 ohms. It was 87 something, wasn't it? And this is the case in every situation. You can have a, well, let's go ahead and do an example. Let's take another array of resistors here. And let's make this one 10 ohms. And we'll make this one 2.2K. And we'll make this one 3.3 megohms. So let's go ahead and throw that into the calculator here. So we've got, and I'll go ahead and do it the way I normally do it, which is 1 over, and then open the parens again, 1 over 10 plus 1 over 2.2 e to the 3, that's another way to do 2.2k, plus 1 over 3.3 e to this, oops, I made that 10 to the negative 3. Why did I make that 10 to the negative 3? That needs to be 10 to the 3. And that one is going to be 10 to the 6, which is megohms. And we'll go ahead and close those parens, close the beginning parens, and then hit the equals button. And we're going to see that it's 9.954 ohms. Now, why in blazes would you ever put a huge resistor in parallel with a smaller resistor? Well, the reason why you would do that is to tune a resistor to be very, very close to a specific value. So in putting the really big resistor in parallel with the really small resistor, we made it almost 10 ohms, but not quite. So you can tweak that down by putting a really big resistor in parallel with a smaller resistor if you need to really tune it to be a very precise value of resistor. Let's see, what other things can I cover with parallel resistors? I think that pretty much covers it. So I'll just rewrite that equation one more time. I'll do it the easier way here. So resistor total equals 1 over R1 plus 1 over R2 plus, and so on, and then take that whole mess and raise it to the power of -1. And that's how you calculate resistors in parallel. Now, let's do something a little messy, because I want to, we're going to be working into Ohm's law in the next, probably the next video is going to be Ohm's law. So we're going to need to start learning how to condense a complicated array of resistors. Now you'll probably never see something like this outside of the classroom, but it's important to cover. So we'll take a resistor and we'll put it like that, and we'll take another one and we'll put it here. And then let's go ahead and bring this out a little bit. Bring another resistor down like this. Then we'll take another one like this. And then bring another one down like so. And then another one out here. And then we'll bring another one down like this. So that looks like a really complicated, confusing mess of resistors. Let's say this one is 1K. We'll make this one 330. We'll make this one 4.7K. We'll make this one 2.2K. We'll make this one 10 ohms. We'll make this one 1K, and we'll make this one, pick another normal value here, 470 ohms. Alright, so we can actually condense this mess into one equivalent resistance. So the first thing you want to start by doing is you work from this side of the circuit inwards to just sort of clean this up. So we can start by taking the 1K and the 470 ohm resistor. These guys are in series, so we can add them together. So that's 1470 ohms. And then that's in parallel with that 10 ohm resistor. So we'll just clean that up a little bit there. And then we've got this resistor here. I'm really bad at drawing backwards. Alright, and then this one here. And then this one. And then that one. So there's the first step of cleaning up that mess. So we've got 1K, 330, 4.7, 2.2, 10, and then the 1470 because we put these two in series with each other, because if you ignore this part of the circuit, those two resistors are in series. So the next phase, and I don't have, I'll just erase this one. Although I probably shouldn't have done that because we could have gone back and done some current calculations, but we'll do that during Ohm's law. So let's continue squishing this backwards. This 10 ohm resistor and this 1470 ohm resistor are in parallel. So let's go 1 over 10 plus 1 over 1470 equals 9.9 ohms. So 9.9. Yeah, none of those digits are significant. And then and then and This is going to get progressively messier as I get bored of drawing neatly. Alright, so now we've got the 9.9 there, ohms. It's interesting how we dropped from 1470 ohms to 9.9 ohms just because we had a large resist, and we ran out of time on the camera, so I had to restart there. Anyway, as I was saying, it's interesting how we went from 1470 ohms down to 9.9 ohms because we had this large resistance in parallel with this small resistance. Anyway, so this one is still 1K, this one is still 330, this one is still 4.7, this one is still 2.2, and then that one is 9.9. So, what's the next part where we need to condense? Well, we can take this 2.2K ohm and put it in series, because we're ignoring this part here, 2.2K in series with 9.9 ohms. So let's go ahead and erase this section here. So 2200 plus 9.9 ohms, we're going to have 2209.9 ohms. And that's going to be in parallel with a 4.7K and a 330 ohm resistor. Now I picked these numbers completely off the top of my head. Like I don't have a book, or there's no rhyme or reason to those values. I just picked these just right off the top of my head. Pulled them out of nowhere. So the next phase of condensing that big nasty mess of resistors that we had there is to put the 2209.9 in parallel with 4.7 and 330 ohms. So let's go ahead and do that. So 1 over 330, plus 1 over 4700, plus 1 over 2209.9. Close the parens, and it's equal to 270.59. Well, we'll say 270.6. Oh, and this was 1K. So now we've got a 270.6 and the 1K, and then of course those two are in series, so then we've condensed that totally random, disgusting mess of resistors into a 1.2706K ohm resistor. And that's how you do that. This is something that can only be learned through practice. So the best way to do it is to just sit down and draw out a big disgusting mess of resistors like what I did just then, and working from the back all the way to the beginning, just condense them out. Say, okay, these two are in parallel, do the math, then redraw the circuit with those out of the way, and calculate it out, and then, okay, these two are in series, so you put those in series, redraw the circuit, and just squish it down just like I did right here until you're down to one resistor. This technique will be important when we start looking into Ohm's law and Kirchhoff's law. So thanks so much for joining me this time. If you have any questions, please feel free to start a conversation in the comments below. If you haven't already, consider clicking about here to subscribe to my channel. Right over here will be a video that YouTube thinks you'll find interesting based on your watching habits. Right over here will be the Back to Basics playlist, and right over here will be a Patreon link for which you can help support my channel. Patreon subscribers do get these Back to Basics videos 1 week in advance. See you next time. Bye-bye.